Welcome to the intelligent electricity distribution system. As you can see right here in front of you, this is the IEDS box which we have in this project, which is to be installed at the customer premises, and that which controls electricity through your load outlets, so that instead of going for a complete power outage, it will restrict electricity as per generation. So as per demand supply, it regulates the load. Here this thing is built with using the core of it is the free scale controller, which you can see, and there is a UART board over here, and this is interfaced to a GSM board, which is the main communication interface to this IEDS consumer unit, and you have the load relays over here, and this is the master circuit breaker. When the IEDS is first installed, this particular GSM interface, it connects to the control station, and if the control station gives it a full permission to apply all the loads, then all the LEDs are switched on, or rather all the load outlets are switched on. The first outlet is basic load, which is basically for lighting and for fans, and this is also for the same. This is for heater, and this is for refrigeration, and this is for HVAC, heating, ventilation and air conditioning. This is the load that consumes the maximum power. Now look at this control station terminal. It's a very simple terminal. We are right now running it on a laptop PC, and we are right now, if you can see, we are connected to the main server, which is remotely located over a broadband dongle. As you can see, that the control station operator wants to control the load because of some demand. Here you can see the load percentage is 100% on the 3 different zones. Now in zone A or region A, it wants to control. So first it presses the load control, then it presses region A. Now it wants to cut off HVAC. So the HVAC is now depressed, and as you can see, the HVAC outlet has no more electric supply to it. That means there is a reduction of the load from 100% to 62.5%. Now we cut off the second load, which is heater and refrigeration, which is a high consuming load, and you can see 31.2% reduction in the load to the consumer. And exactly you can see over here the third from the left bulb, which implies heating and refrigeration, that goes off. Now we are going to cut off the basic load, and the same thing is going to be done over there, and that goes red. And just look at this, the basic load has been load 2 has been cut out. So it means that a total power outage has not taken place, but the load restriction has been done to match supply and demand, and it's only the basic load which is on. Now we switch on all the loads one by one. We first switch basic load 0 to again. We're getting some more power, that switches on. Again, heating and refrigeration is allowed, and you can see this light goes on. And then finally, when you have full generation, you go for the HVAC. And as you can see over here, the HVAC has been switched on, and it's the load full 100%. So this is the basic project which we have over here. Rather than generating more electricity or using more generator sets at our homes, if we can restrict our usage and we can have an equal, I would say, distribution of electricity vis-a-vis supply and generation, we can have better efficiency and we can save energy. And this is a green product. Thank you very much.